Now, let's get to the point. So, a trigonometric ratio, if I call it correctly, is a ratio of two sides in a right angle triangle, right? So the ratio will be constant provided that the angles in the triangle remain constant, even if the sides of the triangle should change. The sides of a right angle triangle are determined by the angle being considered, and that is something very crucial to pay attention to, that the sides of a right angle triangle are determined by the angle being considered. Now the ratios are given by sine, angle, and we can use any symbol for angle: A, B, C, D, element of P, alpha, beta, gamma, whatever symbol we want to use for the angle, it's okay to go ahead and use it. So we have sine the angle is equal to the opposite side to that given angle, or the angle being considered, over the hypotenuse. We have cosine, where we use cos, and we use sin, which stands for sine, and cos, which stands for cosine. So cosine the angle is the side opposite to the angle being considered over the hypotenuse, and tangent of an angle is the opposite side to the angle being considered over the side adjacent to the angle being considered. And I keep stressing to the angle being considered because there are times when you're doing your exam papers, they'll give you more than one angle. There will not only be one angle at a time, they'll give you more than one angle, and you have to know what ratio to use given the angle that you are using or the angle being considered. Now let's consider what are those adjacent, opposite, and hypotenuse that we have been talking about since the beginning of this video. Now let's consider that our angle is here, or the angle that we're being considering is this angle here with this red theta looking symbol in it. Now we have the opposite side going to be opposite of the angle that we're considering. So opposite here, opposite side. Now the hypotenuse is always opposite of the right angle symbol. So we have the hypotenuse, which is normally the longest side in a right angle triangle. Then, naturally, by elimination, the only side we have left is our adjacent side. However, an easy way to aid you in recalling what the adjacent side is to look at that side that has both the given angle that we're being considering and the right angle on that side. So any line you see the right angle and the angle that we're considering on the same line, or sitting, what should I say before I start stuttering, sitting on the same line, that is what we call the adjacent side. Now, suppose I was considering the angle A. Suppose I had a next triangle. Yes, and this is how I draw my triangles. Very ugly, that's why I need tools to help me. Now suppose this was the angle I'm being considering. What will now be my opposite? Now my opposite will not be the opposite that is shown here. My opposite is now here. So this side is now the opposite side. However, and here, where the angle and the right angle is on the same line, not necessarily on the same line, but just to help for identification purposes, we will call here the adjacent side, and opposite of the right angle we find our hypotenuse. Alright, now let's practice some of this, because sometimes it can get a bit confusing for some students to remember how to find their opposite, their hypotenuse, and their adjacent sides. Alright, so for this activity, I'm going to provide 6 right angle triangles, and I want you guys to identify the opposite side, the adjacent, and the hypotenuse given the following angles, the A, B, and C angles in the following triangle. Alright, so I'm going to work these 3 with you, And then I'm going to give you 3 more to do on your own, and you can be able to compare your answers. So let's go ahead. Let's call this 1. Let's call this 2. And let's call this one 3. Now, our given angle here is A. Why do I keep saying here? Here. The given angle here is angle A. Now, opposite of angle A, this side is called our opposite. The side that the right angle and the given angle meets on, we call that the adjacent side. And the side opposite to the right angle is called our hypotenuse. Now let's look at triangle number 2. So our given angle, or the angle being considered here, is angle B. Now opposite, so that's our opposite side. The side where the right angle and the given angle sits on, we can call that the adjacent side. And the side opposite of your hypotenuse, of the right angle, is what we call our hypotenuse. Or you could just automatically put in what is easier for you to identify. So if you can easily identify opposite of your right angle, if you can easily identify opposite of your right angle, which will give you your hypotenuse, and opposite of the angle being considered gives you your opposite, then naturally what is left is going to be your adjacent side. Now, teacher can spell and she pronounces words bad sometimes, but just bear with me. Now it's your time now to do your 3. So pause the video and try these 3 examples that I'm about to show you right now. Now here are 3 triangles, and I want you now to identify the sides of the triangle given the angles being considered theta. Alright, or the symbol here. This is the old looking symbol here. So go ahead, pause the video, and see if you can do this on your own. Now, no cheating now. How many persons got all correct, 2 correct, or 1 correct out of the 3 triangles given here? Remember, the adjacent side, the side that we can say where the right angle and the angle being considered is on. The opposite is the side opposite of the given angle, and your hypotenuse is opposite of the right angle. Remember that. And that's it for identifying your sides. And it is very important to know how to identify your sides, because if you incorrectly identify your sides, then you're going to end up using the incorrect trig ratio, which will lead to you losing marks or getting everything wrong for a particular question. Now, let's have some more fun with our practicing. Now, we're given a triangle and we're asked to write down the sine x, write down the values of sine x, cos x, and tan x. Now, let's go again. So, SOHCAHTOA. So, sine is opposite over the hypotenuse. Cosine is adjacent over the hypotenuse, and tan is the opposite over the adjacent. Now it says sine x. Now let's go ahead. So our angle being considered here is the angle x, and we know sine is what? So let's go again. So sine x is equal to the opposite to the angle x over the hypotenuse. I'm just writing hypo for short. So sine x. Now what's our opposite side? So our opposite side is here, and our hypotenuse, I left out the right angle symbol, so our hypotenuse would be here. So then opposite would be 12 over 13. And you could leave your answer as 12 over 30. No need to write a decimal fraction or decimal. Doesn't matter. Just leave your answer as a fraction. Now cos x. Now cos x is what? The adjacent over the hypotenuse. Now these are opposite side or hypotenuse, then this side is going to be our adjacent. So ADJ. I keep writing the D and the J before maybe I'm dyslexic. Who cares? Moving on. So cos x, the adjacent side is 5 centimeters over, what's our hypotenuse? Our hypotenuse is 13. So it's going to be 5 over 13. So that we get our sine, our cos. Now it's time for our tan. Now tan x is equal to what? The opposite over the adjacent. So what's our opposite side? That's 12 over 5. And we have found our tan x, sine x, and cos x. So you see how it is important for you guys to know how to label the sides correctly given the angle being considered. It's very, very important. Let's have fun with another example. Easy like eating bun and cheese. I don't know. Drinking porridge, drinking a glass of water. Very, very easy. Nothing to scare you right here. Now our next practice question says, given that cos y, cos the angle y, is equal to 15 over 17, find the values of sine y and tan y. Now the first thing we need to do is draw a diagram. Let's draw a diagram. So we know that, in case I did not say this before, we use trig ratios with only right angle triangles. We use trig ratios or cosine or tangent and or sine with only right angle triangles. Only right angle triangles. So let's draw our right angle triangle given the information that we were given, that cos theta or cos y is equal to 15 over 17. So let's go ahead and draw that. This is my see what if I'm writing hieroglyphics? Not funny, but I'm trying. And let's do the boring angle. Alright, let's make this the angle y. So this side is going to be the opposite. This side is going to be the hypotenuse. And this side is going to be the adjacent. So we see that. So we're giving the angle y. Now we say cos is what? So we have a SOHCAHTOA. So cos is the adjacent over the hypotenuse. So our adjacent side is 15 and our hypotenuse is 17. Now we have to find sine and tan. I would know that sine includes the opposite angle, opposite side. So, do we know the value of the opposite side? Now, there are some students who can automatically work this out in their head using Pythagoras theorem. And there are some students who have sorted these ratios. But let us go ahead and just work it out using Pythagoras theorem to find the opposite side. Now, we know Pythagoras theorem. Just a quick informal formula for now. We have a square plus b square is equal to c square. So hence, the square of the opposite plus the square of the adjacent is equal to the square of the hypotenuse. So let's call it O for now because it's the opposite side. So O square plus 15 square is equal to 17 square. Now I want to find O square, which is opposite side. So it's going to equal to 17 square minus 15 square. Using Pythagoras theorem. Alright, remember me can't spell, so I look bad right now. Alright, so opposite square is equal to 17 square minus 15 square. Now let's go on our calculator quickly. And there are some persons who know the square time, so it's easy for them to say 17 square 289 minus 15 square is 225. So O square is equal to 225 from 289. That gives us 64. Now to find the opposite side that we call O for now, it is the square root of 64. And the square root of 64 is equal to 8, because 8 is 64. So our opposite side here has a value of 8. So we use Pythagoras theorem, and there are many videos on YouTube, and I also post a video at a later date on Pythagoras theorem for those who do not recall how to apply Pythagoras theorem. So we know that sine, so we have all our sides. So opposite side has a value of 8, hypotenuse has a value of 17, and the adjacent side has a value of 15. So hence sine y is now equal to the opposite over the hypotenuse, and tan is equal to the opposite over the adjacent. Now what's that value? The value is opposite 8 over 17, and tan y is going to be what? The opposite, that's 8 over 15. So there are times when you may have to find the sides and draw your diagram. Go ahead, don't let it frighten you. And most times you see questions like these on your multiple choice paper. Now, let's look at calculating sides using our trig ratios. So we are given a triangle here, right angle triangle. We're asked to find the sides labeled. Now in this side, we want to find the side B. Now, when we have these questions, the first thing we need to do is pause and get our scientific calculators. Run to the store, purchase them, or go in your room and get one. But remember, it's trigonometry, and we're going to need our scientific calculators to assist us when we are calculating. So now I have gotten my calculator, so I'm now ready. Now the next step after we have gotten our calculator is to identify the sides that we are working with. Because it's only when we identify the sides that we are working with, then we can match it with the correct trig ratio. Alright? So we're given what side? We're given the hypotenuse. This is our hypotenuse. And we're asked to find B. And the side B is opposite to our angle being considered. So we have our hypotenuse and our opposite side. Now, what trig ratio is going to fit that best? Now, what trig ratio has the opposite side and the hypotenuse side? Now, that trig ratio is our sine. So we know sine, and it's good to write back out the formula, or write back out. Yeah, just write it out, it helps us. So sine angle is equal to opposite over the hypotenuse. And what's our angle? Our angle here is 35 degrees. And our opposite side is B over the hypotenuse, which is 16. Now, from here, you're using just basic transposition to find your answer. So you're transposing to find your answer. Now, how would we find the side B? Now, in order to find B, we can multiply both sides by 16. If I multiply both sides by 16 and 16 into itself, once I'm left with only B over here. And then on our calculator now we can calculate 16 sine 35. So 16 sine 35, and that's equal to 9.177. Let's work with 3 decimal places for now. And that's it. So B, and this would be centimeter. Yes, laugh at Mr. Turn. That would be centimeter because it's the length of a side. So the first thing that we did, identify the sides. So identify the sides that were given and the side that we want to find. Then match the ratio. I have 2D. Match the ratio. And then after we have matched the ratio, the next thing to now do is go ahead and transpose to find whatever missing element is there to be found. Let's do another example. Alright, so we have our next triangle here, and our angle is 33 degrees Celsius. We're asked to find the side M, and we're given 25. Now let's identify the sides that we have here. So we have our opposite sides, opposite, and this side is our adjacent. Now if you need to write it out, SOHCAHTOA. Now, what trig ratio has opposite and adjacent? Tan. So we know that tan, the angle, is equal to the opposite side over the adjacent side. And our angle given is 33 degrees. Yes, all right. My writing is beautiful, all right? Do not discriminate my writing. So tan 33 degrees is equal to opposite, which is M, over adjacent, which is 25 centimeter. We don't need the unit for now, just calculate. So to find the value of M, we're going to multiply both sides by 25. So we have M by itself. And let's use our calculator now to find out what is 25 tan 33. So that's clear. So we have our 25 tan 33, and that gives us 16.235. So that's 16.235, and that would be centimeter for the length of our side. Let's try one more. Alright, so let us identify our given side. So we're given our hypotenuse here, and we have our adjacent side. Now, what trig ratio matches the adjacent and the hypotenuse? What trig ratio has those two sides for calculation? And that would be our cosine angle. Cos angle is equal to the adjacent over the hypotenuse. And our angle is 71, so that's cos 71 degrees is equal to the adjacent, which is 7, over the hypotenuse, which is E. Now, for this one, we can use cross multiplication, and let me just use it. Let me just apply the cross multiplication because it's much easier for more students to relate to. So we can cross multiply. So we have E cos 71. We're still transposing, guys. It's all about transposition. All about transposition. I think transposing is also a key skill like algebra, but it is algebra for most students to have. You must have the algebra part. Algebra is in everything, and your algebraic skills go right through a lot of mathematical equations or application at this level. So E cos 71 is equal to 7, because 1 times 7 is 7. We want to find E. We're going to divide both sides by cos 71 in order to find E. So cos 71 into cos 71 goes 1 time, so we're left with E is equal to 7 over cos 71. Let's clear our calculator to 7 over cos 71, and that gives us 21.501, because we said 3 decimal places. So we have 21.501, and that would be millimeters. So you identify the sides you have, you match the trig ratio, and you manipulate your formula using your transposing skills. Alright, so let's continue having fun. So previously we were looking at calculating the length of sides using our trig ratios. Now, in the following questions that we're going to be looking at, we're going to be calculating the angles using our trig ratio. So the steps are still the same. Let's identify what sides we are given. So we see, okay, automatically our hypotenuse. Yes, I don't know why I like to write the U and then write out, stick on the U. And then we have our opposite sides. So hence, what trig ratio matches this? So let's go again. SOHCAHTOA. So realize that our sine matches. So sine, the angle, is equal to the opposite over the hypotenuse. So we have our angle now is called S, so sine S is equal to, what's our opposite side? 4 over the hypotenuse, which is 10. Now, so we have both sides here. So what do we want to find? We want to find our angle. Now when we're finding our angle, we're going to say it's sine inverse of, so sine inverse 4 over 10. So let me write this properly. So it's sine inverse. Alright. So sine inverse 4 over 10. So let's pull out our calculators now and tell me what you get. Alright, so on my calculator, I have to press shift, then press the sign button, then I press my fraction button, and I put my 4 down button, 10, side button out, close my bracket, equals to 23.578. So sine is equal to 23.578, and that is degrees. Now, note briefly and note pantily that if you realize that my calculator is in degrees, please ensure that your calculator is in degrees. We use degrees and not radians for these questions. Alright? Let's try another example. Alright, let's look at another example. So we have, let's identify what sides we have. So we have our hypotenuse, and we have our adjacent. So what trig ratio matches the adjacent and the hypotenuse? Let me write it out again, just for those who may forget between the last slide and this slide. SOHCAHTOA. So we know it's cosine. So cosine of the angle is equal to the adjacent side over the hypotenuse. So we have cosine C is equal to, cosine C is equal to what? Our adjacent side is 6 centimeters over 12 centimeters. Now to find our angle, it's always, whatever the ratio is, inverse. So it's cosine inverse 6 over 12, which is the same thing as what? 1 over 2. Doesn't affect our answer. So we go ahead and put it in our calculators. So we press shift, cosine fraction bar 6 down 12. I keep pressing the thing as I'm using on something on 9. And that is equal to 60 degrees. So C is equal to 60 degrees. And remember, it's an angle, so we write it in degrees. Our final example in this video, we have, what sides do we have now? We have our opposite side from the angle T. This is our opposite. And we have our adjacent side. Now, what ratio matches adjacent and opposite? That would be our tan. So tan the angle is equal to the opposite over the adjacent. Our angle here is called T, so tan T is equal to 18 over 9. And 18 over 9 is equal to what? 2. So then T is equal to tan inverse 18 over 9. And you could put 2, but I'm just doing it exactly as it is. So let us clear and go ahead. So we have our shift, tan, fraction button. So we have 18 down 9, side out to close our bracket, and we get 63.435 to 3 decimal places. So 63.435. So T is equal to 63.435, and that would be in degrees. So the first thing you do, it's not hard. So we know that if it's SOHCAHTOA, so sine, you want to find the angle. The angle is equal to sine inverse, opposite over the hypotenuse. You want to find the angle. We know that's going to be what? Cosine inverse the adjacent over the hypotenuse. And for tan, we know it's going to be, the angle is going to be tan inverse the opposite over the adjacent.